We are going to talk about measures of relative, sometimes it's called measures of relative standing or measures of position or location. You're going to see these in all different ways. But basically what we're doing is we're taking one value from our data set and seeing how it compares to all the others. So for example, if you were to take the next exam, you may want to know how your score compares to everybody else in the class. So that's sort of the idea, is to see how one particular value relates to the others. Okay? Now we need a little bit larger data set for this. So here's an example I'm going to use. It says, suppose the superintendent of HISD has given an aptitude test to 50 of its teachers. The mean of this data, and you know how to find the mean, is 63. So these are all the test scores, or these aptitude test scores of the teachers, okay? Or the potential teachers. I guess, no, it is the teachers. Okay, so this is the data. I have, if you notice, put this in order, so it's in a nice ordered array by columns of 5, just so that it's easy to find anything that we might need, okay? Now, the first measure of location or position that we're going to look at are something called a percentile, okay? And for a percentile, what we have is that after you've put your data into an ordered array, again, this is something that people forget a lot, so don't forget the data must be in an ordered array. Then the nth percentile, a lot of places you're going to see pth percentile, but the nth percentile is a value in your data set such that n% of the data fall below that value. Now, in some books, in some places, you're going to see it says at or below, but we're going to stick to this definition of below, which is the most common, okay? Now, it turns out that statisticians don't universally agree on the procedure for calculating these percentiles. Okay, there's various procedures. In fact, I've really never figured out what Excel does, but it doesn't really matter. Whatever procedure you use, you're essentially going to get to the same place. So you'll be approximately at that place. The method we're going to use is rather simple, but there, again, are more sophisticated methods. Now, if you want to approximate the percentile of a given data value, and notice that it does say approximate because this isn't a very detailed procedure in this case. Usually when I find percentiles, I find the exact percentile. But in this case, we're just going to approximate it. So if you want to find the percentile of a data value, you're going to use this formula. You're basically going to count how many values fall below that data value, divide by the total, n, and then you're going to multiply by 100, okay? So hopefully, I don't think you can see this real well, but I'm going to go ahead and go do an example for you. So I'm going to slide this down. We're over here, and there's our data set up here at the top. And down here, I think you can see this. It says Mr. Smith received a score of 83. Let's go ahead and find his score in this data set. So I want to make the point that we're actually talking about someone who has actually taken the exam. And so if you go up here, you're going to see that here is his test score. Okay? So in order to find his percentile value, what we're going to do is we're going to count how many scores are below him. Remember, these are in columns of 5. So we have 5, 10, 15, 20, 25, 30, 35, 40, 2. So to find his percentile value, we're going to take 42 and we're going to divide by the total number, which there are 50 teachers total that we have looked at. Oops, you're not able to see that, so let me scoot this up, okay? So I took the number of values below the data value and over the total, and then I'm going to multiply that by 100 to get his percentile value, okay? Okay, so let's do that. 42 divided by 50. I'm doing this on my calculator. Times 100. That makes him the 84th percentile. Okay. Okay. Now, so he's the 84th percentile, meaning that 84% of the scores are below his score. So our 84% of those teachers scored below an 83. So he is the 84th percentile. Okay, let's do another example. It says Mrs. Murphy received a score of 56. Okay, and they want to know what percent of the teachers scored below her. Okay, so we're going to go up here and find her score of 56. So here is the 56 that she scored. And we're going to count how many teachers scored below her, the quantity. So we have 5, 10, 15, 16, 17, 18, 19 scored below Mrs. Murphy. So let's go up here. And we have 19 over 50 times 100. Okay. And that makes her the 38th percentile. Okay. And since she's the 38th percentile, that means that 38% of the teachers scored below her. Okay. So this is how we find the percentile of a data value. Okay. Of a data value. But we can also do the opposite. And hopefully you've heard, by the way, of percentiles before. You know, you scored in the 89th percentile. Again, what that means is not that you got an 89, but that 89% of the people who took that exam with you scored below you. Okay? Let's go to the next page. I put the example there at the top of the page again so that we don't have to flip back and forth. So there we are. Okay. And then it says here there are different procedures again for finding a data value corresponding to a given percentile. But one approximate approach, okay, so this time we're kind of doing the opposite. I'm going to tell you what percentile I want, and we're going to find the data value that fits that. Whereas on the previous page, we were given the data value and you found its percentile. So there are various ways of doing this, and we are going to have an approximate approach, which is to find the Lth value, where L is the product of the percentile in decimal form and the sample size. And then you're going to round up to the nearest whole number, always up, okay? So you ready? Let's try it, okay? This time it says, let's find the 30th percentile and let's interpret its value. So what you're going to do is you're going to take the percentile in decimal form and you're going to multiply it by the sample size, what n, right? Remember that n is equal to 50. So make sure that you can see that on the recording just in case. And so we're going to multiply that by 50. And what you're going to get is 15. Okay, and here we got a whole number, so it's going to be the 15th ordered value. Okay, so what you're going to do is, this is the location, okay? So let me put L is for location. And so what you're going to do is you're going to come up to your data set and you're going to find the 15th value. 5, 10, 15. Okay, so the 15th value is 51 in this case. Okay, so the answer is the 30th percentile is equal to 51. Okay, 30th percentile is equal to 51. And so what you're going to do next is we're going to interpret the value. And when you interpret this, again, I want it to be in plain English. and in context. I want you to relate it to the data set that you're dealing with. So what does this tell us? The 30th percentile tells us that 30% of, okay, what are we talking about here? Of the teachers, right? %30 of the teachers had, what do the values represent in our data set? Let me bring this down again. What do these values represent? We got to talk about the data. These are test scores. So had a test score below 51. So you can see that anyone would understand what this means, and it has everything to do with the data set. So this is what I mean when I say interpret something in context. I want to know what the data represents and exactly what it means in plain English. So if someone knew nothing about statistics, they would understand your explanation. Okay? Let's do another one. Let's find the 70th percentile. So what do? We find the location. We take 70 in decimal form, 0.70 times 50, okay? And what you're gonna end up with here is 35, okay? And again, this is a whole number, so it's the 35th ordered value. And again, I'm writing ordered value so you don't forget that it's in the ordered array that you are looking, okay? So let's go ahead and find the 35th ordered value. And so we have 5, 10, 15, 20, 25, 30, 35. That would make it a 72, okay? And so it's going to be the 70th percentile, okay, is 72. And so what does that mean? Let's go ahead and fill this in. I made it a little simpler. 70% of the applicants scored below 72 on their test. I wrote this a little differently to show you that you don't have to write it exactly the way I wrote it as long as you get the correct idea. It turns out that the quartiles we talked about before, and again, there are different methods, so because there's different methods, they won't always match, but quartiles are really just percentiles, okay? They're percentiles that divide the data into quarters. So the first quartile is the 25th percentile, okay? The second quartile, remember, is the value exactly in the middle of your data set. And so it's the 50th percentile because it has exactly half of the values below it. And notice that the 50th percentile is the median, okay? Why? Because remember what the median does. It's the middle value in an ordered array. And that's exactly what the 50th percentile is. They are exactly the same thing. So the median is not only a measure of central tendency, it's also a measure of position. It's also a measure of position, okay? So all these things are basically equivalent. The third quartile is the 75th percentile. It has 75% of the values below it. These are all things that we talked about before, but again, they're actually just percentiles. There is such a thing called a decile. We're not going to talk about them, but you might run into them. And what are deciles? They are percentiles that divide the data into tenths. So the first decile is the 10th percentile. The second decile is the 20th percentile, et cetera, et cetera. So again, quartiles that we talked about before are still percentiles. I would like you to find the quartiles the way we did for those box plots earlier on, but we'll use the procedures that I talked about in this one to find the other percentiles. Okay, so there is some homework for you to do and to practice this a little bit. Okay.